Hello everyone, welcome to Brain Blitz Audios. Today in this episode of VIT Triple E Questions with Solution, we're going to be looking at some questions asked in previous years of VIT Triple E. The subject that we're dealing today is mathematics, and we're looking today especially at questions related to matrices and their applications. So, as suggested by many of our viewers, we've decided to, segregate our episodes based on the subjects and the types of questions we're dealing with. And our videos are more helpful nowadays, as shown by the feedback. So today we're going to continue in that aspect, and here comes our first question. If the matrix 1x1 multiplied with the matrix 1, 3, 2, 0, 5, 1, 0, 3, 2 multiplied with the matrix x1 minus 2 equals 0, then you need to find the value of the element x. Is it minus half, half, 1, or minus 1? Well, the obvious thing here is to undergo matrix multiplication, but then matrix multiplication is different from the usual multiplication that we're used to. So, as we know, a matrix is an arrangement of numbers in rows and columns present inside a square bracket. And in matrices, the multiplication is different. So in matrix multiplication, what we're basically doing is we're multiplying the rows to the columns. So that means that the number of columns here have to correspond with the number of rows in this matrix. So for example, here we have 1 row and 3 columns. Here we have 3 rows and 3 columns. So as you can see, the number of columns here correspond with the number of rows here. So therefore, these two matrices can be multiplied. So let's multiply them. So the first element here will multiply to the first element in this matrix. So 1 times 1. And then plus the second element times the second element. So x times 0 plus the third element times the third element, so 1 times 0. So 1 into 1 plus x into 0 plus 1 into 0, that gives you 1 as the first element of the product matrix. So now, after multiplying the first, column with this row, let's move on to the second column. So here we have 3, 5, 3 as the column. So 1 times 3 gives you 3. X times 5 gives you 5x, 1 times 3 gives you 3, 3 plus 3 is 6, so therefore the second element is 5x plus 6. And now we move on to the last, of the columns in this matrix, so 2, 1, 2. So 1x1 is multiplied with 2, 1, 2. 1 times 2 gives you 2, x times 1 gives you x, and 1 times 2 gives you 2. 2 plus 2 is 4. So x plus 4 is our third element. Now we have one more matrix left here, that is x, 1, and minus 2. So the product of these two gives you 0. So this matrix on the left is a 1 times 3 matrix. So we have 1 row and 3 columns. This matrix here is a 3 by 1 matrix. So it has 3 rows and 1 column. So since the number of rows equals the number of columns here equals the number of rows in the second matrix, then they are multiplied. And the result is a 1 by 1 matrix. So basically, when you multiply the above matrices, 1 times x gives you x, plus 5x plus 6 times 1 gives you 5x plus 6, and then x plus 4 times minus 2 gives you minus 2x minus 8. And this is a 1 by 1 matrix, and the right hand side is 0, which is again can be represented as a 1 by 1 matrix. So this equation in this matrix equals 0. So x plus 5x is 6x, and then x plus 5x is 6x, and then minus 2x is 4x. So 4x, 6 minus 8 is minus 2. So 4x minus 2 equals 0. So therefore 4x equals 2. That means x equals 2 by 4. the final value of x is 1 by 2. So the correct value of x in this set of matrix multiplication is 1 by 2. And if you look at our following options, you can see that option B is the correct answer for this question, which was asked in 2018. Now let's look at the next question. If A is the matrix 2 minus 1 minus 7 4 and B is the matrix 4 1 7 2, then which statement is correct? AA transpose equals I, BB transpose equals I, AB is not equal to BA, AB transpose equals I. So, how do we solve this question? Well, we know the values of A and B, but we don't know the values of their transpose. So therefore, it's a good idea to start from finding A transpose and B transpose. So basically, a transpose is a matrix where the rows and columns are interchanged. So that is the basic idea of a transpose. So for example, if we have A is 2 minus 1 minus 7 4, then the value of A transpose will be 2 minus 7 minus 1 4. So as you can see, column 1 here becomes row 1, column 2 here becomes row 2. So that is the meaning by rows and columns becoming interchanged. Similarly, you have B transpose, that is equal to 4 7 1 2. So 4 7 is the column here, it is the row in this matrix. 1 2 is the column here, the second column here, it is the second row. So now that we know A, B, A transpose, and B transpose, let's verify each option. So A times A transpose. So this means you need to multiply 2 minus 1 minus 7 4 with 2 minus 7 minus 1 4. So 2 times 2 gives you 4, plus minus 1 times minus 1 gives you 1, so that's plus 1. Then you have 2 times minus 7, so that's minus 14. Minus 1 times 4 gives you minus 4, so that is minus 14 minus 4. And next we have minus 7 times 2, that's minus 14. Then 4 times minus 1, so that's minus 4. And finally you have minus 7 times minus 7, so that's 49. And then you have 4 times 4, that is 16. So therefore, the final matrix that we get is 4 plus 1 is 5, minus 4 minus 14 is minus 18, and then 49 plus 10 is 59, plus 6 is 65. So therefore, as you can see, this matrix is not equal to the matrix I. For those of you who are wondering what is the matrix I is the identity matrix, which it means a matrix with its diagonal elements being 1 and the non-diagonal elements being 0. So 1 0 0 1 is an example of an identity matrix. So now we know that option A, AA transpose equals I, is incorrect. Let's test out the next option, BB transpose. So BB transpose means that you have to multiply 4 1 7 2 with 4 7 1 2. So again, you get 4 4s are 16, plus 1 times 1 is 1. Then you have 4 7s are 28, plus 1 2s are 2. 4 7s are 28, 1 2s are 2. Then finally you have 7 7s are 49, and then 2 2s are 4. The final product that you get is 16 plus 1 17, 28 plus 2 30, again here 30, 49 plus 4 is 53. So therefore, as you can see, matrix BB transpose is again not equal to I. So therefore, option B is also incorrect. So now we have two options. AB is not equal to BA, AB transpose equals I. So in both of these cases, we have to multiply the matrices A and B. So multiply matrices A and B means you're multiplying 2 minus 1 minus 7, 4 with 4, 1, 7, 2. Now, when you multiply that, you get 2 times 4 is 8. And then minus 1 times 7 is minus 7. The next element is 2 times 1 is 2. Minus 1 times 2 is minus 2. Then minus 7 times 4 is minus 28. 4 times 7 is plus 28. And then minus 7 times 1 is minus 7. 4 times 2 is plus 8. So you get 1, 0, 0, 1 as the value of the matrix AB. Now, what if we take the transpose here, AB transpose? So that is 1, 0, 0, 1 transpose. As you can see, when you do the operation of transpose, the matrix still stays the same, 1, 0, 0, 1. And again, 1, 0, 0, 1 is the same thing as the identity matrix. So therefore, the correct answer is option D. So in option D, AB transpose equals I, which is the correct option. So that left option C to be in the works. So basically, in this particular scenario, AB is the same thing as BA. However, that is not always the case. So therefore, for this particular option, for this particular question, option C is incorrect because AB is equal to BA. So that's how we've proved that option D, AB transpose equals I, is the correct answer for this question, which was asked in 2018. Let's move on. The value of the determinant delta equals 143, 0, 12, 9, 1, 2, 2 is. So this is a straightforward question. We just asked to find the value of the determinant. And how do we find it? Well, finding the value of the determinant is pretty easy. You have to expand this determinant along one of the rows or columns. So now let's, for the sake of simplicity and convention, expand along row 1. So when you expand along row 1, you have 1, and then the matrix 12, 9, 2, 2. Then you have minus 4 times the matrix 0, 9, 1, 2 plus 3 times the matrix 0, 12, 1, 2. So now we have determinants of order 2. You know, expanding them is quite easy. It's 12 times 2 minus 9 times 2 times 9. So 1 into 12 times 2 minus 2 times 9. And then minus 4 times 0 times 2 minus 9 times 1, or 1 times 9, it's the same thing. And then plus 3 times 0 into 2 minus 12 into 1. So 12 times 2 is 24. 24 minus 18 leads to 6. And then minus 4 times 0 into 2 is 0 again. Minus 4 times minus 9 gives you plus 36. And 3 times minus 12 gives you minus 36. So therefore, the correct answer to the value of the determinant delta is option C, 6. So using, finding the value of the determinant is pretty easy for order 2 because you just have to, multiply the diagonal elements here. However, if you are having a 3 by 3 matrix, then it becomes a little complicated. All you have to do is expand the 3 by 3 matrix along one of its rows or columns. Then you get matrices with order 2, which you can easily find out the determinant value. And by using operators, you'll get the answer, which for this question is option C, 6. So that is the correct option for this question, which was asked in 2018. So option C, which is 6 for this matrix. Now we've reached the final question of this episode. If the equations x plus ay minus z equals 0, 2x minus y plus az equals 0, ax plus y plus 2z equals 0 have non-trivial solutions, then the value of a is 2 minus 2 root 3 or minus root 3. Well, how do we solve this question? First of all, you should understand that the three equations here are to be written in matrix form. So when you write it in the matrix form, you get 1, a minus 1, 2 minus 1a, and then a, 1, 2. So this is one matrix, and then the variable matrix is x, y, z. That equals 0, 0, 0. So the matrix on the right hand side can be written down as just the numeral 0. And now we need to find out the value of a. So how do we find out the value of a? Well, in this question, we have infinite trivial solutions. So basically, a trivial solution is a solution where the values of the matrices x1 to xn are 0 to indicate a homogeneous solution being 0. So these are trivial solutions where you can easily deduct that it's 0. Now, for a non-trivial solution, we need to understand that the determinant of the matrix A has to be equal to 0. So for this question to move forward, determinant of A is equal to 0. So therefore, we'll get 1, A minus 1, 2 minus 1A, A 1, 2. That is equal to 0. So what we're going to do, we need to ensure that this determinant can be expanded with the least possible fuss. So that means at least one of the columns or rows here has to be changed to 0. So over here, column 1 looks particularly inviting to turn to 0. So what we're going to do is we're going to do the following row transformation. So row 2 now becomes row 2 minus 2 times row 1. Row 3 becomes row 3 minus a times row 1. So when we do that, the first row is 1a minus 1. The second row, which was 2 minus 1a, now becomes 2 minus 2 as 0. And then you have minus 1 minus 2a. And the third term will be a plus 2, because there's already a minus 1 here. Now we look at the third, third row. So in the third row, for the first column, the value will be 0 because we're targeting this column to turn into 0. So a minus a is 0. Then you have 1 minus a times a. So 1 minus a times a is 1 minus a square. And then you have, 2 minus 1 times a. So that is 2 plus a. So as you can see, we have effectively turned this matrix into an easier form where one of the columns have the maximum number of zeros in them. And when you have something of this sort, we can proceed to expanding the determinant. So we expand the determinant along column 1. So if you expand it along column 1, you have 1, that's the first element, times the determinant, times these 4 elements of the determinant, which we can write as a plus 2 times minus 1 minus 2a minus a plus 2 times 1 minus a square. And then the other terms here are multiplied to zeros. So therefore, even if we expand them or don't, it doesn't matter because they are going to remain 0 anyway. So we're just, putting brackets there to signify that there are terms there. We're not going to discuss them because they're already multiplied to a 0. And then the right-hand side is still 0. Now, if you notice in the term containing 1, so the first expansion, you can see a plus 2 as common on both sides. So we take a plus 2 common outside. So a plus 2 times, inside the bracket you have minus 1 minus 2a, and then minus 1 plus a squared. So you have a squared minus 2a minus 2 as equal to 0. So from here onwards, we're going to look at our question. Our question's requirement is to find the value of a, and the options given are 2, minus 2, root 3, and minus root 3. Now, if you didn't have those options, you would have to factorize both of these, parts in order to solve the question. But for us, we can see that a plus 2 times that value equals 0. So either a plus 2 can be 0, or a squared minus 2a minus 2 can be 0. So we take the liberty of choosing a plus 2 as equal to 0. So therefore, a equals minus 2. So that means the final answer, the correct answer for this question will be option B, minus 2. And the reason we arrived at it is by first expanding the determinant and then finding out the suitable part which we need to solve in order to appease the options. So therefore, option B, minus 2 is the correct answer for this question asked in 2018. So that concludes this episode of VIT EEE questions with solutions. We hope you found this episode interesting. Please do leave your comments in the comment section below so that we can understand what next to prepare. If you want to access more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. If you want to access more of our VIT EEE playlist, you can click the link to that playlist in the description down below. And for getting the latest updates, you can always hit the notifications button, the bell icon present below the video. So until the next webisode, take care, stay safe, and I'll see you next time.